Alrighty dighty, Math 7, how you guys doing? Hope you guys are all fine and dandy and staying safe and having fun. Alright, so today we have something that we call function rules. So we were talking about the difference between functions and relations, how functions are a special kind of relations. Well, there's mathematical reasons for it. And here are some of the rules for these functions. The first one is actually a diagram. It's a picture. It's a little crudely drawn. It's not great. Don't make fun of me. But what it has, it's called the function output machine. And what we see is whenever we have an x, every x is an input. So we have this x and its input into this function rule. So it's this little function machine, and you could throw it in there, and you could imagine it go boom, 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 bum, 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 bum. Right? It's got a little conveyor belt in here, and it comes out boink, with a y. So again, every x is your input, and every y is the outcome of our function. Right? So that's whatever x value I have, say 2, 0, 10, a billion, whatever. You throw that in there, and then it comes out, blink, our outcome. So here's an example. Let's say our function is y equals x plus 4. So again, y equals, right, that's our outcome, x plus 4. Now, let's say we are putting in the value of 5 into this value. So 5 isn't always the answer, right? This is the function rule. The function. And this is the input, or let's call it the example input. Let's see, that should be an arrow. And our goal is to input our x value and solve for y. Right, we've done this before. We've seen things like this where we have a variable and a value for that variable. Then we substitute it, link, and then we get a number. In that case, we would have y equals whatever that number is. In this case, it's pretty simple. Y equals 9. So again, we have our x value and our y value. Right, let me show you what that looks like in case you guys are having a hard time visualizing it. So y would equal 5 plus 4. Therefore, y equals 9. So where x, so for this function, or at the point x, wow, I was going to put at the in one word. Atha? I don't think that works. At the point x, the function equals 9. That's what this is telling us. At the point 5, maybe I should say at the point x equals 5, x equals 5, the function equals 9. So if I had a little graph here, and 1, 2, 3, 4, 5, then let's say this is 9. So when you're coming along, you're like, let's see, where does the function cross at where x equals 9? It crosses right there. Okay. This is a really crudely drawn graph, but I did it just for a quick visual. Okay, moving on. Now what we do is we organize our functions with tables. So find the ordered pairs, that's x comma y, for the function y equals 3x minus 1. We're going to solve it for these 4 values of x. Okay, so what we're going to have is we have what I like to call t-charts. So t-charts, they come down and you'll begin them with this bit of information. We know what our function is. That kind of goes in the middle. Our inputs, x over here, and we were given these values for x. These are just examples. We don't always use these values. Sometimes we do, sometimes we don't. And we have these x values, and again, look how they descend in order from least to greatest. Now I'm going to plug them in one at a time into this function to find out my output. So again, these are different x values that I'm putting in, and I'm going to come out with different y values. So when I plug in -3, I get 3 times -3 minus 1. Well, 3 times -3 is -9, minus 1, -10. So my ordered pair is -3, comma, -10. Okay. The next value that it asked me to look for is 0. So I'm going to plug 0 in here. Again, I'm rewriting the function. 3 times 0 minus 1. Well, anything times 0, 0 minus 1 is -1. So my ordered pair, or my y value there is -1, x, comma, -1. 0, comma, -1, I should have said. It's x, comma, y. Okay. 4, again, I'm plugging in. I'm going to multiply it all the way through. 3 times 4 is 12, minus 1 is 11. So my ordered pair there is 4, comma, 11. Now 16 you don't normally see, right? Because normally we don't draw our graphs that big, but this is just to show you. This is just an example. So I plug it in. 3 times 16 is 48, minus 1 is 47. So if I drew my graph this big, then I would have this point way up there. Okay. So this, again, you'll hear me call it a T-chart. The reason I call them T-charts is because a lot of times I just do my x and y values like that. But for our sake, we're going to include the function, like we're going to include an extra column where we put the function. Okay, anyway, moving on. You might see a function written like this. Y equals x minus 2, right? That's what we've been talking about. But the other way you see it is f parentheses x equals x minus 2. That's the function of x, right? The output of x, the output or outcome of x. The function of x is x minus 2. You pronounce that, say, the f of x. You'll see this a lot moving into especially high school level algebra. You'll call it f of x equals x minus 2. In this case, f of x is the same as y. That's all we need to know. F of x, same as y. Your book has me tell you that right now. I'm not trying to confuse you guys, but I hope it's straightforward enough to make sense. Again, if you have questions, please ask. All right, moving on. We've got some practice here. So if f of x equals negative 2x plus 5, find f of negative 1. This means find our y when x equals negative 1. Substitute negative 1 for x. So again, this is our x value to substitute. So again, what we do is we have an x value here, but I replaced it with a number. So anywhere I see an x, I'm going to replace it with that value and solve. Negative 2 times negative 1 is positive 2. Positive 2 plus 5 equals 7. So f of negative 1, or the y value, right, is 7. We would say that our ordered pair would be negative 1, right? That's the x value. Negative 1, that's the x value, comma 7. That's the y or f of x value. Okay. I know I'm throwing a lot of new lingo at you guys, but it's straightforward enough, and I think you guys are fully capable of handling it. Okay. Next example, find f of x. So this is the same function, 2x plus negative 2x plus 5. Find f of x when x equals 0. Do it. Plug it in. Okay. I've substituted it. Negative 2 times 0, 0. So f of 0 is negative 5. Again, our ordered pair is going to look like 0, comma 5. Okay. Different function. F of x equals 1/2 x plus 4 when x equals 6. So every place that I have an x, I'm going to replace with 6. And I'm going to solve. Now this, I don't need to do anything with. This is kind of just an entire unit that stays together. We're doing all of our simplifying over here. Again, I need to multiply 1/2 times 6. 1/2 times 6, or what is 1/2 of 6? Well, that's 3. And 3 plus 4 is 7. So again, 6, comma 7. That's our x value, and that's our y value. Okay. One more example. Different function again. Negative x plus 7 when x equals negative 4. Plugging it in. Now notice how my x only replaces this x. This negative sign is on the outside. So I'm going to keep my negative sign outside parentheses. Okay, so that it's going to stay there. And since I'm looking for negative 4, a negative times a negative, we know, becomes a positive. Positive 4 plus 7 is 11. So again, our point here is negative 4, comma 11. Easy peasy. Guys, if you have any questions, please ask. Otherwise, I hope you're doing well. Love you. Bye.